So, going into our senior project, our first term, we are working on an application known as Linguine, which, as stated, is an open source application for natural language visualization and analysis. That's quite a bunch to unpack right now. We're going to go through a brief introduction to make sure everyone's acclimated with the terms that we've been using all semester, so you guys can get a little bit of a better understanding with the project. So, myself, Justin Peterson, and the rest of the Pastafarians team, my colleagues Danielle Gonzalez, Keegan Perot, Jeremy Vasta, as well as our sponsor Cece is back there, and Larry Kaiser, our coach, I believe is in the room but do not see. So, for a brief agenda slide, we want to just do an introduction and overview of Linguine, go through some of the more specific terms as I was saying before, and then basically go into what it is that we did. So this project has been done in the SE department for the past 2 years. So we've taken over a user interface and a lot of information that has already been developed from the year prior, gone through and extended and added some new functionality to that. We want to give a complete overview from the SE perspective as well, so we're going to be giving an overview of the project scope, some of the information that we went and manipulated as we went along, as well as some of the more specific strategies and implementation. So requirements and all sorts of discussion, requirements, elicitation, going through the design, implementation, and testing as well, and some of the metrics that we've collected and some of the information that we've gathered that we'd like to use moving forward into our second term. So overall, as a brief introduction, what is Linguine itself? So as we stated before, an open source web application which is going to take a series of text, it can be from multiple sources. Right now our application is focused specifically on just plain text input. And this text is used to describe language. So anything as far as human language that is taken into a computer and able to be parsed for meaning or recognition. So in this case, we have a bit of domain knowledge. A set of related texts that are structured together is known as a corpus. And then multiple of these corpuses, in plural, is a corpora. This terminology we've been using for conducting what we call analyses or a singular analysis. This set of text will be uploaded into the tool, then is processed using at this point, generic analysis. And then going forward, we select a range of pre-processing options in order to configure this text to get information that is a little bit more relevant to us as we move along. As far as the specific app, this is mainly geared at students who are learning in the natural language processing field. And we have students who are actually trying to complete course activities. We would like this to be a tool that is used for further learning as well as just processing of course activities for natural language processing. Here's a simple home screen of the application. We're not going to be doing a demonstration today, but we will have some home screen shots and a couple of the analysis process as we go along. Very simple user interface. We have the option to upload your text, perform an analysis on it, and there will be some additional documentation to help students along that we have coming in spring. And so, as far as breaking down natural language processing itself, as I had stated before, more the analysis of interactions between computers and human language is the specific definition that we chose to go with. So this is more of anything that is, I would say, so it can be in multiple languages, and the input itself can be in either voice or plain text. It can come from a variety of mediums, but it's basically getting this stuff into, in our case, the tool in plain text, performing any operations for recognition or analysis, and having the computer interact with this language as if it was an actual human being, either by parsing it out and going through sets of information, individual words, going through sentences for recognition of, say, this is a noun, this corresponds to a named entity or a person, but this will be explained much farther in the presentation. An analysis itself is the operation of just uploading the corpus that I described into what we're calling right now a generic analysis. This can be many different types. So basically, the process itself to produce an analysis for the Linguine tool right now is just to take the text that we're uploading, performing this operation on it, and using the pre-processing steps as I had stated. So if you want to, say, remove all periods and separate things out into individual sentences, or maybe split things into individual tokens, meaning you have a single word that means it has its own context in a sentence. And you want to be able to split this word out and go through and see what it means when related to other words in the sentence. There are many different analyses, and it's kind of difficult to describe without the domain knowledge and being able to go through and say all the analyses that our tool can perform. We want to try and give a very high-level overview of the process. And here, once the analyses have gone through to generate a visualization on the other side, right now we have two types of visualizations, just plain text JSON, as well as an output in terms of like a word cloud. Here you can see this output is a little bit difficult to read. And one of the main goals of the tool is to be able to take these raw pieces of output that we're using when we're performing the analyses and make them into a more relevant graphical display that is easier for people who are, one, just learning the natural language processing field, and two, trying to improve their knowledge set in it.
So now that Justin has given you a good overview of the domain, we want to talk about what we did for the project. So the first thing we did when we met with our sponsor was to get a feel for the scope of the project. This was an inherited project that had been worked on previously by 2 other teams. So most of the core parts of the application had already been developed. So these are the items that we identified that we wanted to work on this year. We needed to fix some existing functionality that wasn't 100% correct. We wanted to expand and add new analyses. We wanted to add data visualization, social media integration. We wanted to improve the performance of the application. We wanted to do much more user testing to make sure what we were building was relevant for the students. And we wanted to move the project to its permanent hosting. For the fall semester, we identified these items to complete. We did add additional analyses. We were able to fix all of the problems that existed in the app before that. We performed user testing on 2 different classrooms, and we moved the project to its permanent hosting. So moving on to process. Because most of the app was already there, our job was really to expand on it. So we didn't have a well-defined set of requirements. We had a couple areas that we wanted to explore. So in order to accommodate this in our process, we used Scrum as a guideline. This allowed us to have incremental releases for more frequent user testing, retrospectives for continuous improvement, and we used GitHub issues and Waffle.io to create our user stories for our sprint planning. Speaking more on that, we have different repositories for different parts of our app, but we actually have another additional repository just to track our user stories and the issues, because this allows us to use Waffle.io to make a Kanban board right from that, which allows us to better view what's going on in the project. We can point stories, we can assign team members, we have labeling, and there's a few metrics that we can actually get from this that were really useful. As far as other parts of the process, we met twice a week in person. On Tuesdays we met with Cece. On Thursdays we had a work day. We had virtual meetings on Sundays, and then bi-weekly we had a separate sprint planning meeting. And all of our day-to-day communication was done through a private Slack channel.
So, strategies. What kind of decisions did we make to accomplish these goals in our scope? So first and foremost, requirements elicitation. This is huge. So what does this involve? This involves, well, first of all, the scope for the overarching, all the goals for the entire year. It involves the sprints, each individual iterative or iteration of those 2-week sprints that Danielle mentioned, what we're going to accomplish in each of those, the focus, and the individual features down to what we're going to be putting into the application. So of course, us using Sprint, us using Scrum with sprints, this is an ongoing process. We're going to be doing this throughout. We're going to be eliciting requirements throughout the entire year. So we knew we had to come up with some sort of strategy to really be able to do this well. Because if you fail at requirements, then that's a huge pain point kind of to have to manage. So one of the first things we did, or we do before every single meeting, a few days before, is we send out a meeting agenda. So we know that our time with Cece is limited, our sponsor Cece, and her time is very, very valuable. So in order to get the most out of that, we sent her basically an agenda of what we're going to talk about, any pain points, any questions we have about features or anything like that. And that gives her a chance to review the information so she can be ready, and it makes sure that we're ready as well. So we go into those meetings knowing what we're trying to accomplish or any goals we need. And then finally, of course, during the meetings, we always take notes. Danielle has been acting as our scribe during meetings, and we document those and keep them for posterity. And then, of course, during every single meeting, this one is crucial, we also have to make sure to leverage Cece's domain knowledge. So going into this, none of us had any domain knowledge with natural language processing. We'd never done anything in the field. So we have to make sure to use CC's knowledge in that area to kind of boost our weakness. So we can come in and we can ask her questions about maybe the output of a certain analysis that we don't know what it means. And she can kind of give us a better in detail description of that so we can better know how to visualize it. And then, of course, we maintain transparency throughout this whole process. So we put up our 4-up charts, our time tracking, any artifacts, our burn down charts. They all get put up onto our website so that CC and our sponsor can know that we're on the same page. And so naturally from requirements would normally come design. You'd come up with an architecture from that. Our project might have been a little different because we inherited it from the past 2 years. So they already had a substantial architecture in place. This diagram, sort of at a high level, shows kind of the big parts of it. So first of all, just going over this real quick. First of all, at the presentation layer at the top there, that's basically our front end. That's where we have all of our HTML, CSS, and we can use that part to incorporate visualization libraries. Down at the middle there is our application layer. So there's 2 modules in our application layer, and that's really like the back end part of our application. The first module here on the left is the Node.js module, and that handles getting the static content to the server or to the front end, and it handles any routing. It handles any communications with the front end through HTTPS. And then the other module we have is our Python module, and that part of the back end handles any interactions with the NLP libraries that we're going to use. And then at the bottom here we have the domain layer, which is our Mongo database, which stores information about our different corpus and analyses and things like that. Now, one question that sort of a rhetorical question now, but one question we had to ask ourselves before we started this was, should we refactor this? And the answer we came up with was no, it's extensible. So looking at this architecture as it stands, I'm sure there's ways that we could improve upon it. But redoing the entire thing, we have to really consider the cost-benefit ratio. And if we did redo the entire thing, we probably wouldn't have been able to accomplish any of the goals we set out to in our scope in the first place. So we decided to stick with it, and we've actually been able to expand on it a little bit by adding into the Python side. We could add a nice Python wrapper to interface with one of the new third-party libraries that we're using for natural language processing, Stanford Core NLP. And Justin, I think, or Jeremy will get into that a little bit later.
Cool. And going into a little bit more on the implementation perspective, so as Keegan had said, our Node.js and all the JavaScript side of the application was actually quite rock solid. The main reformat that we had to do on the Node.js and the Angular side was the actual process of going through and completing an analysis. At first, the 1, 2, 3 order that you have was a little bit more convoluted. Pre-processing options, which we haven't gone into too much yet, were actually split up into what they call tokenization types and pre-processing options. And you were able to go through and actually select types of analyses and pre-processing options that didn't mix. For example, if an analysis wanted a tokenized string or something where they were split up into an array of elements with their various tokens, you weren't able to pass that into an analysis that wanted just a plain string sentence. In the previous UI, you could upload corpora and actually pass things that would send into an error state on the Python side. And this would cause errors left and right. This made basically the UI impossible to use. There was a user testing that was conducted last year where basically nothing of value was able to get out of the UI. So we refactored it to be much more streamlined now. There is no way that you can pass it into an error state short of passing an analysis that is too large at this point. Meaning a text file, for example, of like the size of Moby Dick for like 45,000 words, the entire book. That will currently break the analysis, but basically the UI is rock solid going through and actually going through the process of analysis. More specifically to the library integration on the Python side, there were a couple libraries that already existed in our project. The Python NLTK, Natural Language Toolkit, was already used for the previous year. This provided us some limited functionality, but it really wasn't digging as deep as we really wanted this tool to work. We wanted data models and pieces of information that we could use to actually back and process full text strings. The thing is, this is very resource intensive. So the 2 tools that we focused on primarily this semester, Stanford Core NLP and Illinois Curator, these tools both require gigabytes of RAM on the server. They take, at least 30 seconds of time to process a simple text such as a news article. So When we have these libraries that are taking this much time, concurrency is going to be a very primary factor when we're actually going through and processing these texts. It's a really big win that we've gotten these libraries to function, especially with both of them being constructed in Java. We have lightweight wrappers that are open source that we're using to interface with these libraries, but the real struggle is going to come next semester when we would like to make it concurrent. These wrappers currently don't have that functionality, and there are tons of wrappers floating around the open source community to work with Core NLP and Curator. But we want to be able to make sure that we have something that's, one, reliable. They're not going to do a breaking change to the API that's going to bring our service down. And two, that we're actually able to process multiple threads so that a class size of, for example, 50 students could use this tool at once. Going into this, just a very simple image of our tech stack, the Angular, Node, Python, very similar. As far as deployment itself, we handled this issue very early on. It is currently deployed in the liberal arts department namespace. We have the URL up here. If you'd like afterwards, feel free to play with the application. It can support at least up to 15 concurrent users based on our user testing right now. And then testing itself. So there's a pretty extensive unit test suite that already existed on both the Node and Python side, full with generation of code coverage and some built-in metrics that we like to employ. As we added more analyses to the tool, we need to go back and actually finish up some of the unit testing on our end so we can get the code coverage back up to a sustainable level. Right now, we already have continuous integration set up for both sides, and the tests are passing, but the application last year was left in a state where there were unit tests that were written that weren't already, they didn't already pass in the tool. So we've patched those out, and we need to go back through and actually re-implement the functionality to get the code coverage back to a level that we'd like. And as far as going into our user testing a little bit more, we did 2 different courses of around 15 students each. They all had to process a very simple set of text, around 3 or 4 sentences. One of the classes we did Fresh Prince of Bel-Air theme song. The second one we did Hello by Adele. And wanted to do some very simple analyses with the new libraries that we had integrated. We had some pretty nice metrics as far as user satisfaction and reliability in the tool. That's going to be Jeremy going into that a little bit later. But as far as supporting concurrency, it's at a place now where it is good for small sets of text, but we really want it to be that they could throw essentially anything that they want at it. We want this to be a full tool for natural language processing and education.
All right, so I'm going to spend a little bit talking about some of the metrics that we collected and the lessons that we've learned based on them. So first of all, with a fairly sizable sprint 0 and some time to prepare for this presentation, we were able to get in 5 2-week sprints. So here are the burn down charts for each of the sprints. As you can see, we had a tendency to burn down fairly late into each sprint. In my experience, this is fairly typical where the group is working independently because everyone is finishing their work at around the same time, usually nearing the end of the sprint. For some more detailed look into the velocity, as you can see, we had a pretty good velocity early on, and it dropped a bit around sprint 3. Sprint 3 is also where we assigned the most story points. Our estimation was a little off there. It was actually pretty good early on. If we look at the first 2 sprints, we were able to clear nearly all the user stories in them. We assumed that as we became more comfortable with the tool, as we learned more about the tool, our velocity would continue to increase, whereas it actually dropped off. The reason why we believe that happened, discussing it later, is in the first couple of sprints, we probably cleared out a lot of the low-hanging fruit left over from last year, a lot of the easier user stories that we were just able to get out of the way. And ones that we ended up having more trouble with ended up getting pushed into later sprints, and we started having a higher density of those more troublesome story points, or user stories. From our user testing, we did do surveys to collect user satisfaction. Usability is a big thing that we're striving for as far as the scope of this project goes, so we wanted to make sure that the system is both intuitive and easy to use. It is apparently fairly easy to use according to our user testing, overwhelmingly positive note on that. As far as intuitiveness, it's still pretty good. We collected a lot of feedback in short answer form from users to try to improve that, and we're hoping to bring those numbers up in future user testing. So in the conclusions, and we're going to look at some of the lessons we learned and some of the things that we're going to change going forward. So as I mentioned earlier, our early velocity was kind of inflated by these low-hanging fruit tasks. We are getting better at estimating that. We've probably settled around to what is going to be our stable velocity at around 17 or 18 story points. Now that we have the system in a state where we can do regular user testing, we really want to emphasize that going forward. So what we have learned that we need to do is plan our milestones around these user testing goals, make sure that we will have the system in the state that we want to test it when we have the user test planned. We've also discovered, as was mentioned earlier, that the libraries are very resource intensive. I believe Curator at rest takes 22 gigabytes of RAM. Yeah, so concurrency is going to be a very important thing to try to get performance up. I think as we've increased the number of libraries that we're using, performance has become a more critical issue. So in the next term, we are going to want to add additional analysis. We've got these libraries up and running. We haven't really added the analyses for them, but we now have the potential to do so. So that's going to be a thing that we want to add going forward. We want to expand the functionality. We also want to add new visualizations. Now that we have some analyses, we can add some visualizations for them. That is also a high priority on here. We want to make sure that the results are easy to view. We also, as Justin mentioned, want to expand the code coverage because the unit testing suite, we've been expanding the functionality, but we haven't really been expanding the unit testing, so we need to catch up and compensate for that. And lastly, we want to finalize the setup for our continuous integration so that we can more easily push out new updates to a production environment, because again, we're going for lots of user testing, and we want to be able to prepare those as quickly as possible. All right, so thank you for your attention, and we'll now have a few minutes to take questions, I believe.
So it seems like your scope is pretty open-ended in terms of the rest of the project, because it just seems like multiple like different types of ways to analyze things. What are you doing to sort of identify which aspects to actually focus on, or what way, or how to limit the number you're actually, or number of analyses that you're making, or fulfill?
So we set up essentially a roadmap as far as the essential goal that we wanted was to be able to get Core NLP and Curator as functional libraries inside of our system and make sure that we could actually conduct a nice suite of analyses before, like without actually causing any issues or causing any internal server errors like very frequently. And these two libraries provide a very strong suite of analyses that going forward, we really want to try and expand and use basically what those libraries have to offer. There's also a couple neat tricks that the NLTK library that already existed for last semester can provide us as well. We actually ended up stripping out a couple of the analyses that weren't working 100% before moving into our user testing, just so that way we had the clean slate and there was no way that they could potentially cause an error for other users on the system. So what we want to do is really expand on those two libraries moving forward. That's kind of how we're doing our restriction. We've stopped going out and trying to find new ways to integrate into the tool, especially now that we have the resource-intensive libraries, and kind of honing our scope back to make sure that we stay within the bounds of those two, at least until we have some nice visualizations. We have essentially all that we can feasibly use out of those libraries, and then maybe expand further if there's time left in the project.
And Cece's been super helpful too with telling us the best analyses to put in next or things like that. What will give us the most bang for our buck, I guess.
So last year I actually tested this in NLP class, and it crashed during user testing. And so obviously I know you guys are trying to make that better so that it doesn't crash. So the way it's architected, obviously doing the processing takes a lot of power.
Yes.
So is your approach more to kind of make it stable so that it maybe works really slow today, but at least it doesn't crash? Or is it with the hopes that in the future you will definitely add concurrency, and then that will alleviate the problem?
We definitely need to focus on concurrency moving on, and I don't think it's too much to say that we need to focus on kind of both of those things. So the application should probably never go into a broken state. If it just crashes and stops working and someone has to go onto the server and restart it, that's not really the sign of a good application. So we're trying to make sure that we can't get it into an error state. If that is maybe limiting the size of the corpus they can upload or something, then we'll have to look into that. But right now, we have fixed all the broken states that it can get into except for that one. And then, of course, since we do want this to work for a size of an entire class with like decent-sized corpa, we do need to be thinking about concurrency or any way, some certain way to enhance the performance of the application.
Is there like a goal of people that you want to make sure can?
The average class size probably won't exceed about 25 students.
We want to try to shoot for maybe 50 people concurrently using it. So.
Yeah, and that's basically, when we say the metric of 50 people, the user interface itself can handle much more requests than that, but it's, if you were to fire off 50 analyses at once to the Python instance, right now if you send one that's way too big, it will either eventually complete or error out on a timeout. It doesn't lock the user interface at all, but when we say concurrent users, like anyone could click around it and view their analyses at any given time right now, but processing them as a queue, and there's a couple strategies that we could really approach to do that. Either we could do kind of a publish-subscribe model of saying, hey, your analysis will be done shortly, check back on it, and maybe have an instance or like keep a notion of time of how far you are in the queue and process it linearly. But right now what we want to do, because we have a server with enough power, we're able to leverage the use of concurrency. We could have it so that even though there is this one instance of this 20 gig monster that's running in the back end, we could have it so that there are multiple threads hitting it. All of it's sitting on a Java API, so it can handle concurrent requests. It's mainly just doing the implementation in that library wrapper on the Python side so that we could do it.
Okay, let's thank the team. We are Team Breaking Bread. We have our own Mr. Josh Woodward, Jeremy Vargas, Ben Cantor, Craig Cabry, and yours truly, Cox and Chung. So our sponsor is Wegmans. They're actually sitting back there. Welcome home. And so let's talk a little bit about what we're going to talk today. We're going to kick off with the background. So what are we actually doing? Then a little bit about our process, why we chose the thing we chose. It's a surprise. And then talk a little bit about the product, how it was architected. Move on to talking about a demo and what its current state is, and then about future plans.
All right, so Wegmans is a company that's been native to the Rochester area for a while. They've had a college scholarship program that kicked off in 1984. Since that time, there's been $100 million awarded in scholarship funds, and there's around 2,000 applicants per year that are all college students. They currently have an existing solution with an outside vendor. That solution is costly and integrates poorly to the Wegmans core systems that they use. And so some of the main goals that were identified early on were to bring this solution in-house and revamp the current application process. So not only are we building a custom solution from scratch and handing it off to Wegmans, but at the time that we're doing this, we're keeping in mind areas for improvement with the current solution. So the two main components to the application are the actual application process, and then once an applicant has been awarded an application, subsequent payment requests to receive funds.
So let's kick off with our process. This is the Trello logo. That's what we started using, but eventually we moved on to Jira. We moved on to Jira because we decided to use Scrum. There are three main reasons why we chose it, mainly because we had previous experience, but we also wanted to give our sponsors high visibility of the product since we were kind of reframing how the scholarship application process should work. And we also wanted to make sure that there was high visibility so that as we were building this, we could attack the pain points and move forward with that.
So now to talk about our own Scrum implementation. So we are doing 3-week sprints. So we sort of laid out our calendar here. So week 1, Tuesday, we do our sprint planning meeting. Unless it's the first sprint, we also do a retrospective beforehand. Week 1, Thursday, which is our sponsor meeting, we propose a sprint to the sponsor, get any last-minute feedback or changes, and as soon as that's done, we start straight into development. So then the next sponsor meeting on week 2 of Thursday, we do backlog refinement. So this is first is, okay, for the current sprint, is there anything that needs to be addressed right away? Once those are settled, then we go into future items, requirements that need to be elicited further, so that way we don't get too far behind for upcoming sprints. So we continue to develop, and then week 3 Thursday, we do a sponsor meeting where we have a demo of everything we've worked on for the sprint, acquire feedback, and then update our user stories accordingly. In addition, we do stand-ups 3 days a week, Monday, Wednesday, and Friday. Friday is an in-person stand-up as a part of a team meeting, and Monday and Wednesday we do online using our team chat client, which is Slack.
Cool. So for sprint planning, we actually play planning poker. We actually do use the Fibonacci sequence. So that's how we determine how many story points to give each user story. And then when it comes to picking what stories we want to do in a particular sprint, we actually do what's called commitment-based estimation, which means, hey, you know what? I think I can commit to doing these user stories. And so that's how we plan our sprints. And we've had 3 this semester so far.
All right, so as you might imagine, the process is a key part of our project. It's extremely important to communicate the requirements of our product efficiently and make sure that we're always on the same page about what exactly we're building. Initially, we started managing our requirements from a bottom-up approach, and when it comes to traceability, it didn't really work out. There were all these user stories that were ad hoc and didn't seem to be related to anything and didn't trace back to any initial requirement. So we decided for the start of Sprint 2 to take a top-down approach. What this means with us is that we would document use cases as epics within Jira. So Jira offers a nice module to create epics, document use cases, which we would then discuss with the client or with our stakeholders. And then within those epics, we'd be able to create user stories. Each user story had either a development or a product-focused acceptance criteria, or both, so that the stakeholders and our developers would be able to figure out exactly if a user story was successful or not. And again, this top-down approach afforded us great requirements traceability. So an example epic, just to be, an example epic would be just a user can apply to a scholarship. So something that's very, very basic, and we can branch out from there when it comes to development-specific stories.
So next we're going to talk about our user story workflow. So this diagram is basically how a user story moves its way through our process. So at the beginning, so we start out with a user story created from requirements elicitation, and it gets put in our backlog and prioritized. And then during a sprint planning meeting, we take several of these user stories and put them into our sprint backlog. So once it's in our sprint backlog, basically a developer will decide they want to work on an item. They create a feature branch. We're using Git as our source control method. And so they create a feature branch and move into in progress. From here, if they complete the story and all of their tests they wrote pass and it also builds correctly, then they will make a pull request to our development branch for the current sprint. In addition, they also assign 2 people to review the pull request. So if the 2 people who review the pull request think it's okay, and after merging into our development branch, the builds pass and the tests still pass, then the story is done. If it's not okay, then it goes back to in progress. Or if someone's blocked on in progress and doesn't want to work on the story anymore, all they have to do is push their branch up to Git and then put it back in the sprint backlog, and then when the next person wants to go work on it, they can have a starting point based on the previous person's work. So next I want to talk about how we used velocity, and more particularly burn down charts, as a way to sort of improve our sprint planning process, or attempt to. So this is our first sprint. As you notice, there's a lot of large spikes of when we were completing stories. And we sort of looked at this and said, well, this is mostly due to the fact that our PRs in the beginning were just stacking up, and we didn't really sort of refine our process to when are we doing the PRs, like when do they need to be completed by. So one change we made from this was to say, once the PR is submitted and reviewers are assigned, it's assumed that you will review it within 24 hours. In addition, we didn't really meet our goal here. We sort of realized because of sort of the extra technical debt that we missed with Sprint 0, so it's like setting up our development environments completely. So in Sprint 2, we had more frequent, or I guess smaller chunks that for completing user stories is sort of our, going back to the pull request thing of making sure that within 24 hours it gets reviewed. But you'll notice that for the first like week and a half or so we were very stalled, and so this is sort of attributed to requirements default on our part, where a one particular user story involving authentication was more technically complex than we originally thought, and it shouldn't have been put in the sprint to start, and we didn't end up being able to finish it. So moving on to Sprint 3, which was the past 3 weeks. So we started out pretty normal, and then there's this really long line here called Thanksgiving break. And sort of one of the major lessons we learned here was that we greatly underestimated the effect that like a long holiday break would have on our ability to complete stories. So this is something that we'll definitely keep in mind going forward for future sprints.
So now we get to one of my favorite charts, which is the cumulative flow chart. This is basically a snapshot of the current state of the application from the beginning of time all the way to today. And I really like this chart because it kind of shows a lot of things. So as you can see, the orange is to do, and it seems like we can never get past over 50% of what we should do. The idea here is that towards the end of this semester and towards next semester, we can have the to-do list plateau. And then once that happens, we can slowly start carving up at the speed we currently are, and then attain a complete and release product. One thing that I also love about this chart is it shows that Scrum is actually working. So one of the main points of using Scrum was we need to find out what they want. We need to find out what we want, and so every week too, we kind of go back, look at the backlog, and say, okay, what do we need to do? And so what you can see here is little spikes of actual items that we have to do, and so those are kind of coming in regular intervals, and we're achieving a good velocity there with the items that we're completing, and so that's really good.
I'm going to talk about risk management as it applies through our project. Early on, during the move to Jira, we needed to come to a decision as to what tool we wanted to use to do our risk management, and in the end, we decided on Trello because of its simplicity. We felt that Jira would have added an unnecessary amount of complexity to our task. We decided to appoint someone, myself, to be primarily responsible for risk management, to ensure that risk management doesn't fall by the wayside, risks don't go stale, and we can keep track of what's mitigated, what's changed, and so on. We we eventually added a weekly risk management meeting as part of our process to ensure that any risks that that haven't been brought to attention were specifically addressed. Not to say that we didn't do so at all throughout the week, but we kept that one dedicated time to ensure any priorities were handled. Some of the notable high priority risks that we encountered throughout the project were issues with hosting our project. Getting a VM with enough RAM to host our project proved to be an issue throughout the project. Authentication, of course, as mentioned earlier, proved to be a bigger technical challenge than we expected. And then of course the issue of potential scope creep or gold plating throughout the project. There's always the issue of adding more features versus finishing the project on time and pushing out a complete product. And currently there is a lack of automated testing, something which is being addressed.
Cool. So Josh and Coxon talked about the process that we use. I'm going to talk a little bit about the actual product itself. This is the solution we're proposing to the sponsors that takes care of the concerns they have with their existing product. And as Josh mentioned earlier, it's comprised mainly of two parts. The application process itself, which employees will use to actually apply to the scholarship program, and then the payment request system, which employees will use once they have a scholarship granted. So as part of our requirement solicitation, we also wanted to refactor the business process itself. So this represents the application process. So what we've identified here is an employee can do either one of two things. They can start by saving an application or directly submitting it. And the differentiation here is that saving an application allows an employee to save an in-progress application. That is, they don't necessarily need to complete all parts of the application. They can simply save it for later. On the other hand, submitting an application here implies that they have completed all parts of the application, and this includes 2 essays. Hence why we added the saving mechanism, because we don't necessarily expect an employee to complete 2 essays right on the first try. So once it has been submitted, and you'll notice that once they've saved it, it has to be submitted in order for it to move on in the process. A person is assigned to complete a performance evaluation of the applicant. Initially, this is assigned to their direct supervisor. You can think of this person as just a normal manager. That's just Wegman's term for it. And this person is responsible for filling out this performance evaluation, which might include some normal questions and maybe a response to the essay that the applicant wrote. Once it's at that point, it goes to their HR manager, where each location has one HR representative, and they go ahead and approve the performance evaluation. They're really looking for, is there substantial content written here? Does it make sense? So once it's past that phase, it moves on to the administrators of the scholarship program, and we call that state finalized. At that point, the application is completed in its entirety, and it's ready for the scholarship administrators to review and either grant or not grant an application. So at that point, it's ready for, as I said, the administrator to decide whether this person gets the scholarship or is not granted the scholarship. And we call these states, as of right now, approved and rejected. And this, basically, as I noted here, is the entirety of the selection process. If an application hasn't gotten to the point of the scholarship being, or the application being finalized, when the window closes, we simply move everything to an archive state. If a employee saves an application but never really completes it and never makes it through, we just call it archive for the next year. So that's the application process. The next process is a payment request. This is a lot more simple, but basically it's once you have a scholarship, you submit a payment request, and it's either approved or rejected, and you have the option of iterating on that. A quick overview of the actual tech stack. It's a .NET application as mandated by the sponsor. Their entire tech stack is .NET, so they wanted us to use this. And we did decide to go with Angular for the front end. This is a very simple, or I guess it's not simple, but it's an overview of the actual architecture. It's pretty standard. You have an application server here that talks to a database, and then the client talks over the internet and uses their existing infrastructure in order to actually get and maintain the data. So I can go ahead and show you a quick demo that we've prepared. So here's the initial home screen, and what I'm going to do is I'm going to create a cycle. So I simply go to the administrator page, I go to configure cycles, and I start a cycle. And this is where I can fill out information like what's the cycle name. I might say 2016 Wegmans Scholarship Competition. I fill out the windows of when it can open and close, the essay questions, and a performance evaluation. I've already completed this to save you watching me struggle through typing, and you simply just create cycle. And then you'll see right here it's been created. The next thing we want to do is we want to go ahead and fill out an evaluation. Here, the direct supervisor that I was talking about earlier can go and view the list of pending performance evaluations. They can fill out, they can select whatever they want. They can add optional comments. They can say things like great essay, and then another great essay. Submit that, and you'll see it disappears. And then finally, this is the main part, is that an administrator can select the winning application. So in this case, we're going to go ahead and look at this application here, and we can review the performance evaluation as well as the applicant's information. We can read their essays, the evaluator's response, any comments that have been left, and we can go ahead and grant them a winning scholarship.
Now, keep in mind that a lot of the data that we're going to be getting from the for employee information, their location, all of that is coming from Wegmans. So there's a system in place to kind of try and parse through that. And then we're going to talk a little bit about our continuous integration metrics because I love them so much. At the top, we have our success rate. So every time we build, given a specific week, how many of those have passed. And so we have a little dips here and there. But they're keeping us really good, which is positive. And then another one which is really interesting because it's an example of how we mitigated. And so as you can see, code inspection started rising pretty high, and then we decided it's time to do something about it. So we squashed them, and now they're at a constant low. The red lines indicate a build failure, which means that build actually failed, just as a reference. So that's a good insight as to how the project's doing. So our plans for next semester is we think we're going to be doing 4 sprints, and so that kind of falls into place with what we have planned, which is we have to make sure we get authorization and authentication down because that is, again, using Wegmans' existing infrastructure to do so. Then we have to do application process planning or polishing, and then so that's going to finish that. Then we're going to do payment requests, and then final polishing for production because we do want to get this out into production for Wegmans to use. Thank you very much. Do we have any questions?
Keep going.
Where's the, I guess, so do you guys have any concerns, like security concerns with payment requests and personal information? And like where's the application hosted? Or is that something that the Wegmans API is sort of deal with?
So the question was, are there any security concerns with data that we're hosting by the application for the people on YouTube? So if you look right here, our application is being deployed inside of a DMZ, which is a demilitarized zone. Basically, the application is going to be isolated from the rest of the Wegmans corporate network and uses the infrastructure such as Active Directory Federation services in order to actually go through with authentication. So everything's very nicely separated out. Not only that, but we are concerned with the application security itself. And as part of next semester's plans, when we go through authentication and authorization, we'll do an application-wide sort of lockdown, adding permissions, adding roles, and all that kind of stuff.
Professor Reckelmeyer?
So you guys, when you showed your sprint breakdown charts there, you did it in terms of user stories and points for the user stories. Did you ever see a need to break the user stories into tasks and hours?
So what do you mean by tasks and hours, I guess?
So typically in Scrum, you take a user story and then you estimate in hours the number of physical hours it would take you to implement that user story and break it down into tasks.
So we're not doing time-based estimation. We're doing story point-based estimation, which is based on how difficult or relatively difficult we think the tasks are. So we don't actually ever estimate the time it would take to complete a task.
Okay.
Yeah.
So in a 3-week sprint, if you had to roughly estimate for your team, how many hours of work do you have available?
That's an unfair question because we're not doing time estimation. If we do that sort of estimation, then we sort of are now thinking about it in terms of time instead of story points, which defeats the whole purpose.
We don't want to conflate story points with time. That's one thing that we have repeatedly kept ourselves away from doing.
I don't think I'm asking you to do that. That's not the point. The point is, when you're doing Scrum, you have a budget of hours per sprint. You kind of know where you are in the sprint based on how many hours of work you think you have left to do. And then if you have, if you're running out of time, then you can start dropping stories or to make adjustments that way.
So you wouldn't actually drop stories from a sprint, mid-sprint, because then if you're it doesn't offer any benefits in terms of reflecting on what progress you've made in the sprint. If we said we're going to estimate 100 stories or something like that, and we only did like 80% of them, and then we decided at the end we're just going to drop 20% of them, then when we go to look at it during our retrospective, then we say, oh yeah, we did good. We completed all the stories that we wanted to do without any sort of realization of, oh, we overestimated or we underestimated, especially in terms of long-term sort of retrospective fact-checking.
Right. Having said that, we do keep how many hours we work on each story, but we do not use that for estimation. We use that for metrics that we keep. So that's kept track of.
We keep the amount of time it takes to complete some story in mind when we're doing story point based estimation for future work.
Right.
Let's thank the team.
Sweet.
Cool. Hello, everybody. We are Team T-Dial. We have myself, Matt, Piper, Jeff, and Sean, and our product is tax-efficient retirement income, which from now on we're going to call Terry. So, quick overview of our sponsors. We have Belts and Ioni and Associates. They're a financial services firm here in Rochester, and we have two primary contacts within that firm. We have Steve and Mark, who are trying to help us and kind of impart us with their tax knowledge. So let's talk about retirement for a second. So the conventional wisdom is when you retire, you're going to spend your money in this order. So non-tax deferred dollars, tax deferred, and then lastly tax-free. This would be great if retirement or if income tax was a flat tax, but it's not. Order matters a lot when you take money out for retirement. and people know how to save money correctly, the amount of money is not a concern. It's more of how you actually take the money out and how much you owe in taxes at the end of the day. So our goal is to create a product that optimizes retirement income savings and spending so retirees realize the greatest possible after-tax income during retirement years. Now I'm sure some of you are thinking, is there really a big change in tax when you take money out in different ways? And it turns out there is. So if you look at the bottom two lines, taxable income and the total federal tax due, in the first example, they have $155,000 and they pay $23,000 in tax, but the second couple brings in $72,000 and only pays $251 in tax. So let's look at this in percentages for a second. Couple 2 is taking 47% less than couple 1, so you'd think that they would pay about half the taxes. Nope, they pay 1% of the taxes. So there's obviously a huge benefit to taking money out in different ways during retirement.
So I'm going to talk a little bit about our process that we're using for this project. We decided to land on an iterative and incremental development methodology. This seemed like a natural choice for us because when performing an actual calculation, this breaks down into isolated segments of functionality that we can actually deliver as our increments. Another reason is that in an iterative and incremental development methodology, testing is incorporated into every single iteration. So with this project, as you'll find out later, testing is extremely important and it's actually a high priority for us. So we decided to break down into 2 to 3 week iterations with 4 major releases over the course of the year. During requirements elicitation, our gathering, we quickly learned that understanding the problem domain, understanding tax, would be a big challenge for us. I don't know, not many of us are experts on tax, so we needed to understand required minimal distributions, the tax code itself, different retirement account types like 401k, Roth, etc. And we need to have a foundation for how this is calculated. When we were looking at functional and non-functional requirements, we decided on a web application where the sponsors would input data into like a ledger-based style. And also non-functional requirements, we look at correctness, testability, and accuracy. These were extremely important, and these would take priority over usability in the project. As far as managing requirements, we used 3 tools primarily. One tool is our product management tool called Teamwork. This is a tool that we use to estimate priorities with tasks, look at risks, etc. We also use Slack for daily communication amongst the team. And we used email to coordinate with the sponsors throughout the semester. We also met with our sponsors bi-weekly to evaluate our progress with our current iteration and estimate next iteration. Go back a slide. So at these bi-weekly meetings with our sponsors, we would come forth with all the tests that we ran in that iteration, and these would kind of serve as a metric for quality. Again, testing is extremely important in this project. So this would we review our tests during each of these bi-weekly meetings, and then we'd handle changing requirements based on our accepting or failing tests. So just to give you an idea of where we've come and where we're headed, our first 2 releases were building a 1040 form calculation engine and connecting that to a web interface, which we've accomplished. And our next 2 releases are going to be a multi-year calculation. So what this is doing is taking the 1040 calculation engine and looking at it year over year and determining different optimization strategies for that. We're also building a planning and reporting feature of this system. So what that's going to do is, looking at the year-over-year calculations, the customer will be able to see different areas in the calculation where we can optimize based on changing different values within required minimal distributions.
One of our biggest hurdles in the process was the design. I know you probably can't read this, but that's not really the intent. The main goal we wanted to convey here, or the main message we wanted to convey here, was that these are just various designs that we came up with that just ended up not working. We were trying to apply all these software engineering principles, abstraction, and it became overwhelming, and we came to a decision that taxes are just, they're too difficult to do it that way. So we had to go back to basics, and we went back to the 1040 form, and we said, why don't we'll block everything out into the main constructs of the 1040 form. And so what we did was we created a flowchart, an overview flowchart of the 1040 form, and then a process along the side here that explains how to calculate your total taxes due for that year. Here's a simple case. It's the header 1040 where it gets the exemptions and deductions. The blue represent variables that could be in the system, and the orange represent algorithms. This is a little more complex, although it's not necessarily all that complex. Again, the orange are algorithms, but we have some new ones. The yellow indicate internal system calculated values, and then the gray indicate values that are given to us, such as account values. And then we have adjusted gross income. It's a little more complex. You can see we have this new feature down here, or this new symbol down here. It's red, and this is how we kind of grasp the idea of what's going to need to communicate with other pieces. And so you can see this one has to communicate with the total income. And then our most complex system was the tax and credits. This is because it basically needs at least one piece of information from almost every other piece in the system. And you can see it requires these three features here. There's a bunch of inputs, there's a bunch of calculated values. So it was very complex, and it was the most time-consuming section of this design and implementation. And then finally, this is our simplest. It's just a sum, other taxes. So our final design ended up just being this design here, where at the bottom you can see the elements. These are the main components of the tax form that we ended up implementing. The top row is just some plain static objects, with the exception of the 1040 calculator, which it seems to be the main controller for everything, but it's actually just a mediator. It tells the other pieces, it coordinates all the communication between the modules so that they are able to communicate without actually having to need to know about each other specifically. So we could decouple the elements and just have a high coupling for the one class and low coupling for the rest.
All right, so for when we move towards implementing this tax calculator so far and what will become the Terry app with retirement planning in there as well, we looked at specifically languages that we've all used before, which were both Java and Python. We knew both of these languages would be both well suited for the task. Python's math libraries are very robust and would be able to do the computations that we need very easily. And Java would also be just as equally well suited for those kind of mathematic operations. Some of us have also used Scala and JavaScript, which for front-end web development is pretty necessary for our web app. And Scala, which, as you'll see in the next slide, no, maybe not, and so some of us use. Anyway, Scala is used in one of the frameworks that we ended up using. As far as implementation goes, our production environment is going to be on a Windows server. So we wanted to find a technology that would work well with Windows and run. Customers' requirements were reliability, accuracy, and performance are all pretty important. No one wants to sit there for 5 days while you crunch through a million different possible combinations for retirement planning. You want to get the most accurate ones pretty quickly, and you also want to make sure that the accuracy of these numbers are correct. If we're off by $500 every year on taxes and you put that into retirement savings, by the end it's going to look like you're going to have a lot more money than you normally would. Go ahead. And so the technologies we ended up using were, of course, Java and Scala, as previously mentioned, and where you use the Play framework, which is a framework. Go ahead to the next slide, Matt. So anyway, why Play? Play framework is one of the more popular Play frameworks out there. It's written in Java and Scala, and we've been using that because everyone here is written in Java. We can all use that relatively well. We're using the ORM that's built into Play called eBeam, which we're using with a SQLite database. There's not too many concurrent users on this system. I believe 2 to 3. And so contention over the database isn't very necessary, and we didn't feel as though we needed to have a full database service running. And it's easy to install on all platforms. Of course, with a Windows server, it works fine on Windows. In coming up with this implementation, we chose a lot of our design decisions were based on risks that we had identified early on in the semester, specifically for the text calculation. The optimization will be coming next semester, and so while we've taken some steps in implementation to mitigate those risks, they have not been the key risks that we were targeting during this semester for making sure that we had our bases covered. First was understanding text code and its calculations. Again, errors there would make the app almost completely useless. A potentially complicated DB design, and we have mitigated that somewhat by using an ORM, so that we don't have to worry about migrating the database all that much or having to come up with complex SQL statements. We can let the ORM take care of updating the objects that we are using for us. And the final thing, of course, is testing the tax calculation engine for correctness. If it's wrong, it's completely useless, and that's why we have made our biggest stand for this project so far has been on testing with our unit tests, which...
So speaking of testing, so we have two different types of testing. So we're using unit testing as well as integration testing. So on the 1040 form, there's all these different sections, so income, adjusted gross income, tax and credits, all that stuff. So we have individual unit tests that just test those individual sections to make sure those are correct. And then from our sponsor, we received sample tax forms that tested various things. So maybe somebody had most of their income come from capital gains, which is taxed a different way than just regular income. Maybe somebody had more income come in from Social Security, etc. So we have like about 8 or so different sample tests that we can run through, which brings us into continuous integration, which we use Jenkins for. And whenever we push code, it automatically runs it, tests it, and then it'll comment on the commit if there are any errors. And so overall, we have 103 different tests. So we have a couple tests for each section of the 1040 form. And then, like I said before, we have the 8 samples from our sponsors, and we do the same thing for that. So we even test all the individual sections of that form as well as the actual number. And we print out the expected number compared to the actual number, and fingers crossed it's correct.
So far, we have completed our first 2 major milestones, which was first getting a basic 1040 calculation for 1 year, and then also hooking up the web interface to the engine so that we could calculate, again, a 1 year 1040, 1 year of a 1040 form. And so this is what our first iteration looked like. It was command line based. You had to enter it in one by one into a command line, and it printed out the final number of tax due, the total taxable income, and then how much tax that you owed. And then our next iteration is the web interface, which you can see the summary page here is a lot more user-friendly. It included more fields where that would default to 0 for a lot of more obscure ones. Not everyone is receiving money from foreign estate funds, so that's not really one that you have to fill out most of the time, but could be potentially calculated into there. And so now we have this better looking version.
So just to take a look at the semester in a retrospective to see what we did well and what we didn't do well, without a doubt, 2 of our biggest challenges were designing the 1040 engine. We ended up iterating on this design, like Jeff was talking about, landed on something that was a little more designed towards actually calculating individual segments of the 1040 form. Another big challenge that we had was learning the problem domain. Like we mentioned, with learning the tax code and learning how these things work. And that's just a performance hit that we had to take. We just had to spend the time to learn it. We ended up spending a couple iterations early in the semester, learning more about the tax code, becoming very familiar with the 1040 form. If we had to look at some things that went really well this semester, we are happy with our methodology choice of an iterative and incremental development. Like we talked about, by breaking the 1040 form into its individual components, these served as increments that we would deliver, well tested in each increment so that we could cumulatively calculate the 1040 tax itself. Again, low requirements volatility, so luckily the tax code doesn't change every day. So we were able to learn the tax code, and then we could just move forward with building these different steps towards the final calculation. Finally, using the play framework has been a good decision for the team. We've had very low friction with getting the engine built, aside from designing it, and actually using our tools has been pretty smooth. So moving forward, our next steps are going to be spending one iteration in spring on polishing the UI and building our persistent database for account information. And then we're going to continually acquire more test cases, look at edge cases in the calculation to see if we're missing anything. Currently all our tests are passing, but there's always going to be an edge case we want to examine. And we have our last 2 releases coming up in the spring semester. And what they are is a year-over-year calculator. This is the big piece. This is the planning system. And then also the prediction and reporting system. So this is going to contain reports and graphs, and this is going to allow the customers to examine different areas where the retiree could potentially optimize their retirement. This concludes our presentation. We'd now like to open up to any questions. Great.
Is security in the scope of this application, or is it just you're focusing on the algorithm?
It's an internal tool with very little sensitive information that's in it. There's no social security numbers. There's nothing like that. It's just how much money you make and how much you put away. So it's not no bank account information. There's no account numbers or anything like that. So security isn't too high of a priority with this.
Is it something, so you're going to have a web interface, or you have a web interface that you're developing beyond the command line interface, but is that just going to be something that is a desktop application for the future, or?
It's going to be an internal tool. The design choice for a web interface is rather than having an application that's installed on every single desktop in this office, you install it in one place and everyone just accesses it with their browser and can access it while they're away as well. Go ahead.
Just to clarify, does that mean that your target user would be someone who works at the company filling this in for someone else and the retirees themselves are not filling out?
Yes. Paul?
So are you guys saving information on the users, or is it going to be kind of a like, oh, since we're input it once, this is half of the information that you can hand off to them? Or will it save so that like if they come back next year, you can tweak the numbers a little bit?
So the idea behind this app is to forecast what you're going to do for retirement. So how much you're going to be saving and then how you're going to take that money out once you finally retire. So what this is going to be doing is sort of trying to project what your future is going to look like. And then as they keep coming back to this financial firm to, make sure that they're hitting their marks, everything's that if they've had an unexpected life event, that everything's still on track, they'll be able to update the engine and then run it again and say, all right, this is what it's looking like for your retirement picture. Craig? Sorry, are you?
Go ahead, Craig.
Yeah.
So Piper mentioned that the tax code doesn't change day to day, but it does change year to year. How do you account for that?
So the current tool that our clients use basically uses some sort of inflation thing. Tax generally rises with inflation other than large swings and changes in the tax code. We're making it so that our tax bracket is configurable. As one of the objects as you saw out there is the tax bracket. So as that changes, if more are added or removed, that we can adapt to that on a year-to-year basis, and moving forward that projection can change. But for the most part, it's simulating using some sort of inflation factor so that it's hopefully close. I think I cut you.
Yeah, so I guess similar to Craig's question, what's the maintenance of this project going to look like moving forward when there are like major swings in the tax code, for example, or a change in how the taxes are calculated?
We're hoping to just have a simple file with a configuration, or sorry, it was originally going to be a file. It's going to be a part of the database now where we have a configuration panel that the customer wants to be able to play with inflation rates, whether or not it's going to go, and growth rates specifically on accounts as well. Whether or not a 401k is going to perform 8% every year over year, or 10% is pretty important. So there's going to be a configuration panel where they can change those kind of things, add tax brackets, et cetera. Go ahead.
So with a strong emphasis on testing, have you or considered doing test-driven development or computer-driven development?
So for this first part of the project, no, only because of the like how much we had to learn about the tax code. So it couldn't be like, or well, like we could just, put in like a sample 1040 and then come out with the result, but our main focus was learning how it actually got the result, so we didn't focus on test-driven development. We focused more on learning how it actually worked, developing that, and then regressing back and fixing anything that we missed along the way.
Essentially, the problem was we don't have a whole lot of domain knowledge when it comes to taxes, at least in this much detail. I mean, I do my tax on TurboTax every year, so that's easy. But so the major problem is if we did sort of test-driven development, we would be writing tests that we didn't actually fully understand yet. So we were presenting these features to the customer and then comparing it to their numbers to make sure that we were getting it correct. And we figured that the iterative development was better for that.
Let's thank the team. What we've got for you guys today is a project that's centered around one pervasive and growing hobby around the world today, and that's this idea of bicycle touring. So basically what this is you start from point A, and that could be your house, it could be your friend's house, a neighboring town, across the country, and you get on your bike, you strap on your backpack, your saddlebags, your tent, and you kind of just start riding. You might have a plan, but at the end of the day, you're kind of enjoying the road and the world at 20 miles an hour instead of 60 or 500. So if you've ever tried to organize a trip across the country, whether it be plane or car, you kind of understand the different logistical nightmares that can come up when you do this sort of thing. And that's no different here. So imagine you're this cyclist here, and you're out in the Badlands of South Dakota, the plains of Wyoming. You know what your plan is for today, but you're not quite sure what you're going to do 10 days down the line. You want to make sure you have a place to stay, a place to eat, a place to repair your bicycle, because a failure in any one of these things could be a serious problem for you and your ability to stay alive. So we're by Climatic Complexity. I'm Matt, Steve, Jesse, and Ethan, and we're going to be talking today about how we're going to solve these problems around bicycle touring. But first, we're going to talk to you about adventure cycling.
Adventure Cycling is our sponsor, and they're an organization that provides resources for cyclists. They started out as Bike Centennial in the 1970s and have ever since been inspiring people to travel by bicycle. Some of the things they do include organizing large cross-country tours, releasing regular magazines, and they also have forums and places for people to kind of blog about their biking experience. One of their biggest things that they sell are maps, physical maps with different routes and services catered towards cyclists. The organization has invested lots of time and money in researching these routes that are perfect for bicyclists across the United States, and these routes have become known as the Adventure Cycling Route Network. With these kind of maps, you do know where you're going to be 10 days from now and where you can sleep and live and eat. You can even see in these maps, they contain all the information you would want about a service, including when they're open, what their contact information is, and what services are provided any specific route. One thing that Adventure Cycling has also been promoting is the USBRS, also known as the United States Bicycle Route System, in addition to its own cycling routes. While this organization sells its route systems via the maps, the USBRS will look more like the U.S. interstate system. Bicycle routes even have their own little shield and markers.
Yeah, so today we're going to be talking about the Bicycle Touring Digital Companion, which is basically a digital presence for adventure cycling that will promote the cycling routes, services, and even blogging stories and narratives to give users the ability to kind of share what they experience along the route. Yeah, so three of the things I'm going to talk about here, just as far as what we considered a strong contender for like architecturally significant requirements and really impactful on our scope, was just the journals or blogging component of the application, where users would be contributing and posting their own stories and where they've gone, where they've been. The ability to find services on a map, like mentioned before, it's very important to know what's going to be up along the road and where you can eat and sleep. Also, a really strong point that was brought to us very early in the project was offline capabilities, because in a lot of the areas you might not have Wi-Fi or 4G or any sort of internet information, and being able to still access the information we listed above is super important, because you can't just open up your phone and notice, oh hey, this app is basically pointless 90% of my trip.
All right, so we've been envisioning this product, and now we have to kind of choose a process that we'll be using to implement that. So when we were developing our process, we realized it had some realities that we had to face in order to choose a process. The first one was this is an entirely new application. Some of the other cycling-related apps that we've heard from this week and last week are ongoing projects year to year. So we do need some structured requirements work that our process can support. We also have our team, us four, had low domain experience in the cycling world, and we also really had no experience with geospatial information systems. So the process needed to support research spikes and also more documentation than the standard Agile process would have you do, so we can communicate with our sponsors about the things we don't know and also amongst ourselves and our team. And finally, we do have a remote sponsor. They work out of Missoula, Montana, so there's a huge time zone difference involved. Also, we still want regular collaboration with the sponsor, just not infinite involvement. We probably can't meet with them more than once a week. We have our regular remote meetings. So this kind of accumulated into choosing the Open Up methodology. You've probably no one in front of us has heard of this before. But I had worked with Dr. Hawker with this, and the main selling point for us was that it has a really good developed wiki with a bunch of best practices and technologies that we'd use for requirements, elicitation and testing, and whatnot. So we want that. Just a takeaway for you guys. The main thing to know is that it has 2-week iterations, just like some other standard Agile processes. But you have to understand the phases. Iterations belong to one type of phase, and throughout the year, we'll be going from inception all the way to transition. The inception phase was mostly about meeting the sponsor and formalizing the scope of the project. Basically, should we go ahead with this project, or is it too complex to even start? We are currently in elaboration, where we're trying to construct what's called the executable architecture, meaning beyond just the documents for our architecture, we need to have something that runs, and with that base, we can expand upon it in the next term and in future iterations. Also, before you switch slides, there's the transition phase as well, which is used to perform final bug fixes, and then to ensure the sponsor has the appropriate documentation in order to maintain it on their own.
So at this point, we've talked quite a bit about the product that we're building here, and you may realize that it sounds pretty ambitious, kind of like riding your bike across the country. And that's true. It's also true that this sort of project is not really, as a result, well suited to kind of fitting into one senior project life cycle. And so what we ultimately had to do was decide which features were going to be out of scope for our senior project iteration of what this project is going to be and what we can commit to delivering at the end of the year. And so ultimately what we decided we weren't going to focus on now was the idea of journals. So the ability for a cyclist to blog about their experiences, upload photos, and then trace their route that they took across the country. Ultimately, that's not part of our first delivery. Now, that's not to say they won't be in the final system, and they're still definitely part of the architecture and the vision, but the actual functionality won't be there. And so you might say, Matt, well, that sounds great, but how did you kind of come to this decision that those features were sort of the least important and that you were instead going to focus on the services and the maps? And so this was basically how we did that. Next slide. So open up provided us an avenue to really efficiently track whether we were creating a tenable number of high priority requirements, essentially. And in that sense, Open Up was a really great choice for us. It allowed us to kind of recognize this issue that we were going to have with scope. And the way that happened is during the inception phase, Open Up recommends like some serious risk management activities. So every Thursday we meet and we go over our risk charts of our top 20 risks in the project. And we kind of re-rank them, we talk about them, we create risk mitigation strategies. So the one major risk that we identified early on was this idea of too many high priority features. And so what we did was we went back to the sponsor and we asked him to kind of reprioritize these issues so that we could get a better idea of what was going to be most important to the system. And what fell out of this around week 7 or 8 was that we realized, all right, there's no way that this first iteration of the project can contain all of the architecturally significant things. So we're going to focus on services for now and kind of leave out the blogging aspect. And in a way, this was also really valuable because it gave us what we're going to call the interim reflection, which is essentially a chance to look back and see which processes were working for us and which processes weren't. And basically, we came to the conclusion that we need to start implementing our baseline architecture earlier, which would have given the team and the sponsor a better insight into what was happening with the project. And just in general, that we needed to adhere to Open Up better. And as a result of that, we kind of chose our metrics. And first was a slippage chart, which just kind of measures where our deliverables are for different iterations of Open Up and whether or not we're successful in delivering those. And then in the same vein, we have an IDRE chart, which allows us to track whether our defect detection and removal is adequate for iterations that we already passed and kind of adjust the scope of that activity as a result.
So with our new features, we prioritize services, as Matt said. Obviously, learning more about services and being able to search them were key components to the application now. and also people being able to add services that they ran across or be able to comment on them. And of course, as we've mentioned before, saving map information and service information offline would be a key feature that we'll actually talk to more in our architecture slides. But around this, some of the key quality attributes we wanted to highlight included usability, persistence, and security. Adventure Cycling's real goal here was to get a digital solution for their maps and kind of entice new users that maybe have never heard of adventure cycling or even thought to travel by bike. And so we wanted to release a polished application, which means having something that's really nice and looks like an application. As for persistence, and we'll talk a little bit more about this in the architecture design, but the idea that you might be offline and adding services or commenting on things, we want to make sure that your contributions don't get lost. And so as we have these two different states of truth, what's on your device and what's on the servers, and chances of conflicts, we need to make sure that all throughout nobody is losing information, that nothing gets lost, and everybody, no one feels cheated out of what they've been typing. And then finally, for security, we're handling adventure cycling data. That includes which users are members, and so also thinking about administrators, we needed to be very thinking of forethought about how we would handle authentication in scenarios like that. Finally, we did have some large constraints on our architecture design. A big one was using a Windows server, which we'll talk more in the architecture design. Also, doing a cross-platform design that maybe didn't allow for two native solutions on Android and iOS, and Ethan will talk a bit about that next.
Yeah. So we kind of narrowed it down to two choices towards the beginning, and that was really whether we were going to use React Native, which had came out super recently when we were making this decision, and it was super cool, but it was very unstable. The other choice, of course, being Apache Cordova, which is mature cross-platform, but only offers a mobile web view. So there's some limitations and factors in that. So ultimately, which one did we pick? We picked Cordova because it's so much more mature. And then to kind of get around the fact that it was going to be a mobile web app, we are using Material Design Lite as far as to use aspects that kind of look like the Android UI. As far as using components, though, we're using React.js for web, and we're using Redux, which is an implementation of the Flux architecture. Right here we can see that Material Design Lite does kind of mimic the Android look and feel. Thank you, Matt. And we are also using Leaflet.js to provide a map system for our application. So in this way, we're hoping that despite it only being a mobile web view, we get all the functionality and usability aspects of a standard Android application. And then we chose this over using some other UI frameworks like Bootstrap, because we don't want it to feel like a web app, like you're going to a website and this is your experience. We want it to feel like an app. So on that point, we'll talk more about the back-end technologies.
Yeah, so I'll just touch on the back end here. We have the back end split into two server instances. We have the application server and the database server. The application server will serve all of the map-related information, whereas the database server will contain the service-related information, including hours of operation, names, phone numbers, etc. We also have the option to have our application split across regions of the United States. So if we want to have one hosted in the east, like in Virginia, or perhaps one in the west, then Cyclists will be able to communicate with the server quickly if they're in Montana or on the East Coast somewhere. A unique choice for us was using CouchDB. If you ever heard of the CAP theorem, you can choose two of consistency, availability, or partition tolerance. We don't really care if someone uploads a service in Virginia and then someone in Montana doesn't get it.
for a few minutes, really. So as long as we have eventual consistency, we're safe. The good news is when you have a database of this style, synchronization and replication of databases is really easy. So in fact, we are using PouchDB on the client device inside the web view. And if you're not familiar with that, it's just a re-implementation of CouchDB in JavaScript. It follows the same protocols, so we can replicate our service data right from our database server into the client device without any type of custom REST API. We still need some stuff on the Node.js side for authentication and registration and whatnot, but it kind of makes it a bit simpler for us. Finally, on this slide, we're using Node.js just to have a unified, everything's in JavaScript. Just hopefully simplify things for us. And I'll just go a bit into our technology for mapping. The other team that was up here last week that was doing mapping is using Leaflet as well. But we did identify some constraints in terms of, or trade-offs in terms of the technologies available. On the left, we have the Slippy Map technology, which is where, and Google Maps uses this, you divide your maps into a bunch of rectangular, or a bunch of squares, and then depending on where you are in the map, the application will load in only those squares that are relevant. And these are raster images, which will take up more space than vector data on the right. Some more recent apps, including the Google Maps app, use vector data. So download sizes are smaller. Everything can be shipped to the device in one file. The problem is all of the work that's been done in the industry on the vector style maps are proprietary and cost money. So we didn't go down that route. We went the route with the raster tiles, which are free, and we're going to have to download more data to the phones as a result of the raster architecture. But there is a lot of community support, so we believe this is the correct choice for us. We're also doing testing, of course. We're using a pretty standard test stack for web technologies. Of note, though, we'll probably try to use Appium towards the end to automate device testing. And we're also going to, since we're using React.js, we're going to do shallow rendering, so we can test out components on the components that we use without necessarily bringing up a whole browser to test them. There are 3 unique testing considerations for our team. The first one is that how do we get our sponsor in Missoula to run the code and have them share the same experience we see on our end. So we'll be working towards that next semester. Next semester we'll also try to do some beta testing with members to make sure that this app is actually useful for the people we're designing it for. And just a final note on testing, we've had some difficulties with iOS just in terms of the startup costs, meaning we have to get devices, we have to get a Mac that can run Xcode, and we have to get our own developer accounts. So at this point we all have our developer accounts, so hopefully next semester we can actually build the bicycle touring digital companion for iOS.
So I mentioned before that Open Up gave us an opportunity to do our interim reflection. Well, here's our for real interim reflection. So basically what we realized in the second half of this semester was that we were by far more productive when we worked as a group, but due to concerns about credit hours and Ethan and Jesse living in Irondequoit and other things like that, we weren't able to get that much group meeting time. And as a result, a lot of our implementation and architecture decisions kind of suffered. And what this essentially led to was this slippage 101, which is actually really bad. This means that for our average deliverable, we were delivering it twice as late as we were expecting to. And as kind of a solution to solve this, we kind of realized we needed to really buckle down and get more group time and work through some of these difficult, architecturally significant decisions. And our solution to this is going to be this intersession boot camp. And you might say this doesn't have a high chance of being successful, but the team's already committed to being here in Rochester in the second week in January, and we're working right now to plan out specific weekly deliverables. We're going to continue to have meetings with our sponsor weekly during that period. And we're planning on about 15 to 20 hours at least of group work in those 3 weeks there. So that's how we feel will be the most successful moving forward.
So
once again, we are Bike-O-Matic Complexity. We'd like to thank you all again for listening to our presentation. We also like to thank Bellino for his excellent images donated for the presentation. And now we'll open it up for questions.
Can you talk a little bit about the life cycle of the data when, because I know you have Node and then you have Couch. So is Node only a relay to then persistent Couch, or what's?
It'll be for registering. So you still need an account on the Couch DB server, so that'll get you your first account. It'll also do anything that can't be solved with the just basic synchronization.
So do you ever talk to Couch directly, or is it always?
We expect that most of the communication, especially for just synchronizing service data, will happen directly from as a replication from Couch to Pouch.
So you're doing some stuff with user submitted data. Have you thought how you're going to moderate that data?
Yeah, that's actually a huge point that we've been working with the flows with the sponsor. Do you want to
I'll talk to it. So essentially what happens is there's the service that you view on the application when you're online, and this, for all intents and purposes, is a master copy. And whatever is there is, agreed that it's correct if it's displayed. And so what users can do is they can submit changes to this, and these changes get displayed as what are new changes. And when other people come into the application, they can indicate whether these changes are accurate or inaccurate based on check-ins. So that's how it's going to work right now, and that's you can see like a high level of trust in users, and then in order to kind of counteract mistrusted users, we're going to also implement some moderator features like banning of accounts and locking of services for verified information and stuff like that.
You mentioned kind of focus on UI, and at the same time you're talking about developing cross-platform on devices that have many different screen sizes and stuff. Are you relying on Cordova for the majority of that, or are you addressing that directly? What's your strategy?
So we're actually only targeting phone-sized devices. We're not caring so much. We've talked with the sponsor about this, about tablet-sized devices.
Okay.
Towards one of the, we do want to get a web view like that, just a normal website up eventually. We're going to try to, at first, try to use Cordova's, because Cordova can compile for just a website as well. We'll try that out initially, but right now the main focus is on just the app. And in terms of the app, both iOS and Android will get the same app-like feel, even though iOS will have to use the Android style.
Do you have a test plan in terms of actual hardware testing, or are you relying on virtual testing? What's your thoughts there?
So we all have Android devices, so we're routinely building it for that. We're going to have to figure out our real hardware strategy for iOS over intersession and into the semester. But we can also virtualize the iOS app as well.
Keegan?
So I thought your guys' rationale for like your decisions seem pretty solid, but I noticed that there are definitely substantial benefits to using that paid caching rather than the other one that was like like information. I forget what the two were called.
Yeah.
Did you guys ever talk with your sponsor maybe about possibly using that, or did they say no, don't go down that route?
I'll speak to this. So one constraint that we didn't list is sort of that. Well, first of all, Adventure Cycling is a government organization. They're a nonprofit.
But it's not a government. It's just a nonprofit, 501c3.
Nonprofit.
Yeah.
And so as a result, they kind of have a tight budgeting schedule. And what we have set up right now for our project is $300 a month. And that's for all hosting, third-party integrations and things like that. And we basically looked at everything. I think was it $50 a month for up to a certain number of users for this vector map data?
Yeah, and if you wanted to have paid users eventually, like if they added in-app purchases, the Mapbox, which is basically the only company to look for here, limits usage of their free API to 1,000 users in the case that your app is paid, which isn't very good towards the mission of Adventure Cycling.
Right. So in the event that they wanted to sell for example, like promote their paper maps to the app and have them be purchasable, we would then get spiked up on our vector costs. So.
The other thing too with the paid vector data API is that you can only cache data that comes from the API itself. You can't offer some type of prepackaged download for the entire route. So the user themselves would have to like browse the entire route to get all the cache data. Our current solution would be to package all of the rendered tiles for a specific route in one place, so you could get as many routes as you want.
All right, let's start the